this topic, text-to-image synthesis. Generative AI has taken up the world by storm. ChatGPT or text-to-video and stuff like that. So it's quite famous. So I just aim to make you appreciate how text-to-image synthesis is the very base ground of generative AI in the computer vision space. So I'll just enter the presentation mode. Okay. Yeah, so a little bit about me. I am in electrical engineering and I joined the Cynaptics club in first year, to which I owe, the knowledge that I've gained and experience that I imbibed during my 4 years. Okay, so let's start with some pictures as to how the state of the art models are performing. So this is the Imagine model released by Google. So you can see the prompts, these are not very standard prompts. These are sort of, just built upon imagination. And you can see how well the model is producing these images. Now, please note, this model is not open source. So I have taken these images from their research paper. But what they quote is, really nice. See the resolution here. It's quite high res, and the details are there. That is a really good thing there. This one is Party. This is Party's auto regressive model. So again, this is also released by Google. Yeah, and again, it's also generating a good deal of images. Though this is of a lower resolution than the previous one, Imagine, because that contains a super resolution block. I'll be discussing that later, but let's just focus on now. Okay, so this one is the DALI 2 model, yeah, and you can see Barna mad scientists mixing sparkling chemicals and Shiva and it's generating really nice. So now let's see what is the ground reality of these models, yeah. So, oh god, this keyboard. Okay, so this is the stable diffusion model, which you can actually try yourself on Hugging Face. It's open source, and I just put a prompt AI takes over. Now, to look at it, it's generating a lot of gibberish. You can see there's no sense to the characters it's generating, and it's sort of like scary. Now this one is boy dressed in school uniform. You can see how well the face has been generated. I don't need to emphasize on that. So this has been generated from DFGAN, trained on MS Coco dataset, which comprises of images from around 80 classes or so, or I believe more than that, and has been trained on 595 FIPOX. This one is this prompt is on people dancing on the streets. You can see how abhorrent the faces are. They are indistinguishable. So this brings us to the point that is generative AI is what we actually think it is. So this is a it's a very simple prompt. Friends holding hands. Now this is generated from an unofficial implementation of Imagine. Now contrast it with the previous images that you saw of Imagine in the first slide. So you can see it is not able to even form the hands. Yeah. Though there is some sort of degree of quality in the faces compared to the rest of them. So what went wrong? So firstly, I would like to break your notion that most of the research papers that exist, they basically present cherry-picked results. Yeah, they are not to be trusted, even if it comes from a very good source such as NVIDIA or Google, because as soon as you run their implementations, you will find the truth sooner or later. Also, another factor could be that most of these companies don't want to release their best models, obviously. This is the world of capitalism. So, who wants to let it go for free? So, and low parameter checkpoints are often available on the net, so that is there. Also, one more thing which I found is text to image fails on generating very complex prompts or very complex actions, such as we saw that for a very simple prompt, friends holding hands. So it has to generate the images of the fingers, the edges that are there. Now note that for most of the training data that is available, it's of 256 cross 256. MS Coco is of 256 cross 256. Now and 5 billion data set is of 512 cross 512. So it's not a very high quality image that is being put into the model, and also these data sets are gathered from Google or scraped from the web. So it's not that you're getting a very cherry picked image for you to train. So there goes various transformations, cropping and all. So the data that is being fed to the model for training is not of a very high quality in general for training large models. So it often fails on performing, developing simple things such as twisting legs and so on. Okay, so we have seen the images. I believe it's very pertinent of us to talk about how ML is working here. So there are three approaches of how text-to-image generation works. One is GAN. You must have heard of it. If not, then I'll explain in simple terms. So there are two networks, generator and discriminator. The aim of the generator is to take a noise vector. What is noise? Gaussian noise. Think of it as a random vector. Now that noise is upscaled, upsampled over multiple layers to generate the image, and the task of the discriminator network is to check the quality of that image and see if it is generating that image as per the specifications. Here, the condition is the text that you are feeding to the model. For example, in this figure, it's shown this plant has a small round violet petals with a dark purple center. So this is a very this image is from a very starting paper that dealt with the text-to-image synthesis. The second approach is variational autoencoder. So what we saw right now, just to recapitulate, we had a generator that took a random vector, upsampled it over and over to generate an image. Here, we are doing an opposite thing. Here we take an image, we convert it to noise, or more specifically, a probability distribution vector. That is an embedding vector in this case. Though this is very complicated, this is actually from the DALI paper, which you might have heard on news that DALI Mini is now available. But the core concept is thus: you convert an image into noise or its equivalent embedding representation, and then you take another block to convert that noise vector back to a certain representation or the original image that is meant. But abstain from explaining this. That would take a lot of time. Now, the third approach, and probably the approach that is dominating the text-to-image space, is the diffusion. Yeah, so I actually explain this with the next slide. So this is how diffusion process works. You take an image, you train it to generate a noise vector, and from the noise vector you take it back to generate an image. Seems like a variational autoencoder, right? We were doing the same thing. But here, note the difference between variational autoencoder, that is the VAE, versus the diffusion process. For diffusion process, we have two separate networks. For one network, we take the image, convert it to noise, and then using another network, we convert it back to image. Here, a single network is used to perform both the tasks in two processes, that is the forward diffusion process and the backward diffusion process. So coming back, this is the architecture that the authors of Imagine actually proposed. So they have a text-to-image diffusion model, and then so the target is, as I said, is to generate images that is replicant to the training data. So as I said, training data is of 256 cross 256, mostly or 128 cross 128 in user terms. You increase the size of the image, your model size increases humongously, and so does the inference time and the training requirements. So they take a 64 cross 64 image here, and then they upsample, perform super resolution on it, as in increase the resolution of the image, and that is done by AI, because here you have a single pixel and you have to extrapolate into, let's say, 4 or 8 pixels, depending on the scaling factor that you use. Here, I believe a factor of 4 is used. Yeah. So for that, you need a predictive model. So that's how things are done. So just to summarize, as I said, one is the generative adversarial network, second variational autoencoder, and flow, basically VA and flow based models are the same. The core difference is that here you run a embedding here that is replicant to the probability distribution of the image. Now I keep on saying probability distribution of the image. What does it mean? Now there is a fact that you must learn that summation of Gaussian noise results in a Gaussian noise that has a certain mean and a variance. So image is nothing but a tonal distribution of the different colors within an image. So it can be modeled by a Gaussian distribution. Those in electrical would run in their random processes course in the third year. Yeah. So, but here you actually generate a complete noise. And for diffusion-based model, you have a simple network doing that. But the thing with diffusion model is that you have the more number of layers you have, the better is your result. So diffusion models run into 80 GBs, 100 GBs or more. Yeah. So with better results, you are actually sacrificing your performance and the storage requirements on that. So let's talk about some latest developments in this field. So, I mean, with ChatGPT and that is launched commercially, now people are running, these companies trying to deploy their generative models into their various applications, for example, Gboard and Microsoft Bing that is already using ChatGPT. Yeah. And also, deployment of diffusion models on mobile devices is actually gaining traction, and that too billion parameter model. So I'll be discussing this in the next slide. And also, I mean, we are no one to talk about this, but still, there has been certain regulation, talk of regulations on who owns the image. Whether if you provided the text prompt, do you own the image, or does the model own the image, or does the creator own the image? So those are beyond our discussion. So I'll just show this demonstration video of stable diffusion on call. So note here, it took 14 seconds on a mobile, that to a billion parameter model. Now the image that I showed you of stable diffusion in which I put the prompt AI takes over, it took me 60 seconds to generate that image. And they generated it in 14 seconds. I mean, let's see what went behind it. I mean, how were they able to do this process? So there is something called model optimization. Right? You don't just develop a model architecture and say, yeah, this is done now. I just need a whole data center to deploy it. That's not done. So there are three techniques which you should just know on a very superficial scale, at least. One is the pruning process, in which you actually remove the connections between the different layers, right? What you call as synapses, I call them edges or whatever you can call them. So essentially, each in a sequential model, each layer is connected to other layer. For example, if in the first layer there are 5 nodes, and the second layer there are 4 nodes. So each of these 5 nodes in the first layer would be connected to each node in the second layer. But in pruning process, we see which node is least dominant in the generation of the predictions, in our case the images, and that during the whole inference process and training process and all, and we remove those less relevant nodes and keep only the relevant nodes. In quantization, it's really simple. You just convert the floating point accuracy of the weights, model parameters. The third one is actually a sophisticated technique, knowledge distillation, in which you take a very big model and you have a smaller model of a very lightweight architecture and you train it. So, remembering, you can read more about it, but model, see, most of the AI space, in my opinion, has saturated to, but at least in text to image, it has saturated to a point where creating more and more models of increasing parameters would yield little to no results on when compared with the baseline. So, current research and current developments are focused on how to optimize it. Deploying your edge devices, your mobiles, and so on. So, techniques like these are being explored. So, talk what is further to text to image. Text to video is the next big thing in research. I believe some of your seniors are already doing some project on it, so you can ask them. So, thing is that it's difficult because the spatial and temporal knowledge needs to be taken into account. The relative positioning of the pixels that was being taken in the text to image, but how they change over time is a challenge. And incorporating speech is even a bigger challenge. So there exist some models, make a video by Meta, Cog video, Imagine video. So I'll just show a clip onto how is the quality of image generation at present. So you see, it's just sort of look like the images overlap with each other or joined with each other. The quality is really poor. If I am to just move this video a bit ahead, so you can see the quality is not there. And what is and to this date, no text to video model is able to incorporate speech because speech is actually a very independent domain of image as such, and you have to capture the movement of the mouse to actually do that. And to make the mouths of the individuals, or let's say to generate voices of animals, to make their mouths move is actually a very small detail that that the model cannot generate it with the training data. Otherwise, it has to be very large, and it would just blow off the computation requirements. So, to explore more on this topic, which I thought would be a very nice addition, because most of you are already might be researching on ChatGPT and all. So you can look into this guy's repo, Phil Vance. Now this repo contains unofficial implementations of most of these state-of-the-art models, not only on text to image but on other domains as well. You can read about developments on text to image on this link. Slides will be shared with you, I believe. So this not concerned. Now, having few spaces is something which I urge all of you to explore, because not only it contains deployed models on text to image, but also it contains clones of ChatGPT and so on and so forth, which you can actually try. And for most of the models, the code base is actually visible, so you can tinker with it, right? And it goes without saying, yeah, you cannot move ahead in the field of AI if you have to do something new without reading research papers. I mean, that is the only source of knowledge, because honestly speaking, AI is totally a mathematical course, a mathematical domain. What we feel, I mean, when I was in first year, I used to feel that it's nothing, it's just coding, calling functions and, just arranging things in a way that it looks logical, it generates logical results. But, as you dive deeper, as you look into more advanced domains, then you find that it's more or less maths. That's why we have master's courses in machine learning, and most of the big firms, Google, Facebook, Amazon, they take master students only for their AI-based programs, their AI-based roles. Yeah. So yes, at least generate a novitiating interest in reading these research papers. But for undergraduate, I believe learning the applications is more than enough. With that, I would end my slide and ask my colleague Hasan to his solution.
Okay, so if you have any question regarding Aryan's slides, I think he will be open for questions as well. Because I believe no one has understood more than 20-30% of the stuff that was said. Because I think that was the purpose here, to show you what's out there and to sort of give you a taste of what is there to achieve in this field of artificial intelligence and machine learning. And so, yeah, I think that purpose has been fulfilled. Okay, now, okay, so I'll change the method a little bit. I'll be trying to talk with you guys a lot more, and we'll dive less into technical details here, because I believe ultimately you'll learn the technical details as and when the time comes. But I'll try to show you some of the concepts that are behind some of the famous applications of AI. Okay, so something about myself here. I'm a final year student in mechanical engineering department. My intern was in fractal analytics, and I was a quantum machine learning intern there. And before that, I interned with the electron ion collaboration, in collaboration with Jefferson Lab, and there I worked on machine learning applications for high energy physics applications, uh, basically related to. So you have heard of Large Hadron Collider, right? So there is a bigger particle collider that is being built, which will so they'll probably start building a new collider in 2030 in, I think, France, I guess. So for that, they are doing the software work from now itself, and they are developing AI-based models to detect new particles in particle physics. For example, you must have heard about Higgs boson, right? So that was detected completely using analytical techniques and statistical methods. However, now even the physics community it is moving towards AI-based application, AI-based techniques to detect new particles, because ultimately AI is about recognizing patterns, right? And as we have larger and larger systems, for example, larger particle accelerators, we have like very large data sets that run into petabytes and even more. So we need faster techniques to analyze that data and to generate reasonable conclusions. So how many of you have seen that image of the black hole at the center of Milky Way galaxy? Has anyone seen that? Yeah. So that black hole image is also an interesting example of how this field of data, analyzing the data is changing. So to generate that image, data was taken from different radio telescopes spread all across the earth. So essentially there is one telescope in Peru in South America, there is one telescope somewhere in Australia, and data from both of them and multiple such other telescopes are combined together to generate one single image. And now the data that was generated by these telescopes was so large that it was cheaper to just put the hard drives on a plane and ship it to the data center instead of sending it via the internet. So that is the scale of the data that is being generated nowadays. And to analyze such data to generate reasonable conclusions, reasonable inferences from such data, it is important to develop techniques that can utilize such large amount of data quite efficiently. So, for example, Aryan just gave the example of diffusion-based models and generative adversarial networks. So these models generally tend to improve as you increase the size of the data set. Yeah, so that is like a very generic high-level introduction of what can be done with AI. So yeah, a quiz question. Can anyone connect these four photos and tell me what this is about? Yeah, that is Gary Kasparov, obviously. Huh? Yeah, that guy. Yeah, he's a Dota player. And anyone for the remaining two guys? I mean, you can use Google Lens if you want. But okay, any ideas how these four people from different walks of life might be related? What? Yeah, on the right track, but not quite. I mean, I need a specific answer which is quite relevant to this interaction that we are having. Huh? Yeah, these four people, there is something very relevant to our discussion that has happened with them. Some life event has happened with these people. I mean, any guesses? Random guesses. I mean, with Gary, you can I think guess probably what has happened with these people. Any random guesses? Yeah, right. So all of these four people, these are like world champions in their own fields who have lost to AI. So first guy is Lee Sedol. He's a South Korean Go player. He lost to AlphaGo. Second guy Gary Kasparov famously lost to IBM's Deep Blue, although he later defeated it and then they refused a rematch. The third guy is I think is Luigi Villa. He's a backgammon player. and he was also defeated by by a rudimentary computer program in 1978. And third guy is like his some Dota player who was also defeated in a 1v1 match by an AI. So as you can see, AI is already taking over. So it is quite important that we understand what it is and understand where it can be applied. So let's quickly look at different applications of machine learning. So obviously finding exoplanets, then trading stocks, chatting with humans, filtering content, and maybe in the future it will take over the Synaptics Club workshops and I'll not be needed. Okay, so let us quickly look at what older AI systems were. So before 2010, 2015, most of the AI systems had a component which was sort of hard coded. So you could say that all the researchers took some, they made some experts to sit in a room and they analyzed how these experts work and tried to replicate those things by using computer programs. So very famously, Gary Kasparov alleged that in order to specifically defeat him, IBM had taken the help of his rivals, and that the software that had defeated Gary Kasparov was not truly an AI, but it was rather a heuristics-based program that was, created in order to specifically defeat Gary. So what we ideally need from a modern AI is that it should be, in principle, able to learn from scratch. Then perhaps given the amount of computational resources that is required to deploy such models, to train such models, often specialized hardware is used for these modern artificial intelligence models. Finally, it is very data intensive. The more data you feed into an AI model, as of now, the better results you get. Then obviously we want it to be more human-like, and finally we obviously want the AI to be better than humans, so that we can use it to do things that we ourselves cannot do. So this was the more generic part of the presentation. Now, does anyone have any questions in general regarding, say, anything AI or machine learning? Because you see, this is an interaction, so ideally I'd like to have some questions and not just speak. Yeah. Oh, this. So basically, quantum computing is a new paradigm of computing, which. So have you heard of Moore's law? Moore's law, which states that the processing power increases exponentially, and every few years the processing power of a chip doubles. So essentially, what is happening that we are making the chips smaller and smaller. So at one point, we will reach a stage when the chip will be so small that the classical physics will not be applicable for that physics. So you cannot write like V is equal to IR is equal to L di by dt, something like that. So you cannot write those kind of equations. You have to treat the current as like a wave of electron, because then the scale becomes so small that individual electrons are basically circulating in a circuit. So that basically gives rise to some special properties to these electronic circuits. So which is the basic of quantum computers. And when you use those computers to basically run ML models, that is called quantum machine learning. So it is an emerging field. You do not need to understand everything about quantum computing or machine learning to try it out. There are a lot of resources. Uh, yeah. Any other questions or any follow-up questions? Yeah, so basically in quantum computing, what is so there is a special gate which essentially is like a matrix multiplication. So if you have say in classical computing, you have 10 bits. So you can write it as a vector 0, 1, 0, 1, 0, 1, 0, 1, 10 numbers in a list. So essentially, what is machine learning? It essentially tries to build a model. A model is nothing but a sophisticated matrix, right? So if you are able to do matrix multiplication on any system, ideally, essentially, you can use it to do machine learning. So in quantum computing, what happens that matrix multiplication becomes a very fundamental operation. So just like we have gates in classical computer, we have matrices. Uh, the gates in quantum computers are basically matrices. So those matrices can be applied on certain states to get certain results. So that is essentially very much looking like machine learning, where you have an input, you apply a model and you get an output. In quantum machine learning, you have an input, you apply some gates, you get an output. So there is the analogy for quantum neural networks. Yeah. Any other questions? Uh, okay. Then I'll quickly give you a taste of what reinforcement learning is. So the strategy of reinforcement learning is basically how we teach our kids, or how we teach our pets. Basically, if they do something right, we give them a reward. If they do something wrong, we penalize them. And so over time, they learn to do things that are beneficial for them, and they avoid doing things that are not beneficial for them. For example, if you want to train a dog, and once the dog sits down, you give him a candy. If the dog is not sitting down, you say beat the dog with a stick. Although it's not advisable, uh, that is an example. So that concept has been borrowed into machine learning, and that has been named as reinforcement learning, where you have an agent. Agent is essentially anything that takes a decision, and environment is the environment with which the agent is interacting. So the agent has to do something to the environment. For example, I pick this up, I drop it. Okay, so the environment then gives a feedback to the agent that whether your action is correct or not, how advisable that action is. Okay, so what I'll do now is I'll tell you how a specific software called AlphaGo, AlphaGo Zero, the model that is behind the most advanced recent models which are used to play sports like chess and Go are developed. And I'll give you a very simple explanation of how that model works. So in order to understand that, we need to understand what is a game tree. So basically any game which is played by two players can be represented as a tree. For example, a tic-tac-toe game can be represented as a tree. So we start off with an empty board, then the player one makes some move. So there are say nine options for the player one to make a move. Then the player two has to make some moves. Then the player one will again make some moves. So that will lead to creation of a tree. Now the key to winning any game is to find, like, in this tree, which path should I follow so that I end up on a winning node, right? So that is essentially the task of any AI that has to play a game. It has to. So this tree can be very very large. For example, in a game like chess, this can have billions of possibilities. If I remember correctly, in the game of Go, the number of possibilities is more than the number of atoms in the universe. So essentially, the task is to find an optimal route to go to a winning position. So, to do that, the current state of the art model uses two key concepts. One is a Monte Carlo search tree, and second is a neural network. So, these two models combine to make the most sophisticated of the AI systems. So, Monte Carlo search tree is very simple. So, essentially, what you do is uh, first you start from somewhere, okay? You start from a base node and you go to any random node that you want, okay? And since you want to evaluate, is this node like, is there a possibility of winning when I start from this position? So what Monte Carlo search tree does is that it starts making random moves from here on, and it will keep making random moves until it reaches a decision. So it will, like, put across here and then a circle here and then across here and a circle here, and uh, so it will play a random game and see what the result is. Once the result has been achieved, for example, the circle player wins, it will assign like a number 1 to this, that this is a winning position. And then it will move on to some other position. Then again it will play a random game and find what the result is. And then it will come back and assign a win or a loss to this particular move. And this process is repeated for several number of times. That is, from this position, different positions will be explored, and say if this is a winning position, then after playing randomly, there will be more winning states than losing experiments are done, and finally every board is assigned a certain winning probability, and based on that, the AI can play that if this position is occurring, what are my options and what are the winning possibilities of each option. And based on that, it will take the decision by choosing the move which has the highest winning probability. Now, the problem with this approach is that when you start making random moves, there are so many random moves in many sports, many things, that it is not possible to get an answer within a reasonable amount of time. So, this is where neural networks come in. So, what we do, instead of making random moves to reach the end decision, what we say what we say to the neural network is, look, take this position, look at this position and tell me what are my chances of winning. So it is like if you have played high speed chess or like even chess without thinking. So you just see the board and you see, okay, the queen is hanging and you just capture the queen. So that kind of approximations that is what the neural network tries to make. It sees the state of the board and it tries to predict whether how much probability does this particular state have of winning. So now we have replaced essentially the third step, the simulation step, where we randomly made moves until we reach the result by a neural network, wherein we assign a probability based on the state of the system, based on the placement of the pieces on the board. And finally, we backpropagate these results to get uh, probabilities for each state. And now, with neural networks, what happens is that you need a lot of data to train it, and all of that data comes from the billions of nodes that are there in this tree. So, as you see in the game of chess, this tree will be very large, and there will be like in every iteration of the training of the neural network, different probabilities will be assigned to the board, and the neural network will have to correctly predict the probabilities of winning for each given state. That is the essential idea uh, of uh, AlphaGo Zero, that it combines the Monte Carlo search tree with neural networks. So finally, what happens is that the neural network learns to sort of predict uh, good probabilities for these nodes in the search tree, and this neural network can finally be used to play whatever game that you want. So to summarize, there are basically three steps. One is self-play, neural network training, and comparison between old and new networks. So yeah, the final part which I missed, the comparison between old and new networks. So for example, you have one model which you trained. So when you update the parameters of that model, you compare both of the models. Is my older model better or is my newer model better? If the newer model is better, then you replace the older model by the newer model, and then you continue the training. So that is essentially what is meant by comparison between old and new networks. So the Monte Carlo part is the self-play part where the model plays with itself in a sense that it is making moves and assigning probabilities to different stages of the play. And the neural network is basically the model that is generating those probabilities. And finally, we need to choose the best model which is available. So yeah, I think it's not a very good idea to give more details into this, although we have more slides. I'll take up any general questions regarding this if you have. Yes? Yeah, so in this, basically, when you look at the loss function, uh, you are essentially penalizing the neural network for not making the correct, for not guessing the correct probability. So that is the reinforcement part. So this is essentially a deep reinforcement learning model wherein the uh, model is basically trained. Uh, so you see, there is no essentially there is no labeled data set that we are using. That we have a cat and it is labeled cat. The model has to play with itself and essentially from its experience in the simulation phase, whatever results it is getting in the simulation phase, that is essentially the reinforcement that the model is getting. So if at a particular position, the model explores 10 moves and sees that it is losing in 6 of those moves and winning in only 3 of those 3 of those positions, then it is probably a bad position to reach. And so it will try to avoid that position altogether, right? So that is where the reinforcement idea comes into picture.
I just add to that. Essentially, the reinforcement part is the policy that we use.
Yes.
So the policy essentially determines how we are reinforcing the model, right? So what policy do we judge in order to reward the model? Do we make the model reward if it reaches the end result or it reaches a some favorable result according to the need? So that what is essentially termed as reinforcement.
Yeah, so if you look at this formula, so this formula basically determines which node we have to explore next. So this formula essentially captures the essence of reinforcement learning, wherein you want to choose the best possible next move, but also since the model has not learned completely, there is possibility that there is some other move which has not yet been explored and it might be a better move. So the model has to make a balance between exploiting the existing knowledge, that is, it should choose the best possible move, and exploring the unknowns in the environment. So this particular formula is used to basically select nodes in the first process, in the selection process, as to how to travel along that tree, and that formula essentially is the core of reinforcement learning.
Sir, this reinforcement learning, basically right now we are training the model.
Yes.
And when it is trained, can we say that it is now like it now knows that at this position of the that TikTok game, uh, where should I place my next X or O?
Yes.
It has learned it. Basically, there is a data set and it has an information that
You are talking by learning, you mean memorizing.
yeah, yeah.
So for smaller games like tic-tac-toe, you can say that it has memorized. But for example, if you take a game like chess or go, the models, even after looking at a particular position, the model is not 100% sure that this move is a winning move, but model is like 90% confident, 98% confident, 99% confident. So you cannot really say that it has memorized the move. Rather, uh, it has it has gained a certain amount of experience that in these kind of positions, these kind of moves are more favorable. So, uh, because what will happen if it will see an unseen position which has never occurred in the game before, it will still be able to make reasonably correct predictions. So that is the proof that it has not really memorized anything, but rather it has gained some experience, that it is able to recognize some patterns in the game.
And how will someone come across with such equations?
Huh?
How will someone find these equations? Like, how will they know that how I have to assign this for reinforcement learning? How I have to assign the value that this position will be favorable?
Yeah, so you start with some random values. So the model initially will predict some random values, okay, which will make no sense. But uh, as the model trains, it will gradually gain experience. Like if you tell a player some rules of chess and just give him a board, initially the player will make like very random moves, and slowly the player will start to recognize patterns. So in this case, what like very specifically what happens is that some probabilities are calculated based on the Monte Carlo search tree. So uh, without like taking into account the predictions of the neural network, and then the predictions generated exclusively by Monte Carlo and predictions generated by the neural network are compared. If you look at the loss function here, what it takes is it takes the value generated by the neural network, and then it takes the reward that is propagated in the Monte Carlo search tree. That is that. The difference of both of them is taken, and the policy that the neural network is generating is compared with the policy that the Monte Carlo search tree is generating. So there the comparison happens, and that is what basically we try to minimize the difference between what the neural network is predicting and what the non machine learning algorithm like Monte Carlo search tree would have predicted. had there been no neural network. But like it is a simplified version of that because Monte Carlo search tree is itself using outputs from the neural network. Yeah. Any more questions? Anything that uh, because I understand this is quite confusing and yeah, please.
So back then in our teenagers and childhood, we used to play game like chess games with the computers and all
Yes.
that. And in that there would be levels like hard,
Yes, yes.
medium. Is that something related to the tree that you're making, or is it something
Yes,
different?
I think essentially what you can do is so when you come to this Monte Carlo search tree, you can repeat the experiment for some n number of times. So you can decide that okay, I am going to explore 1600 moves starting from a given node. So that number n essentially defines the strength of like how much the depth of the evaluation is, and that will essentially determine the difficulty level of the program. So if you are doing a very deep search, if you are looking several moves ahead, that will be a very powerful system. And alternatively, one can also say that a model that has a neural network that has been trained for a lot of epochs, that neural network is likely to be more experienced than a neural network that has been trained for less number of epochs. So these are the two ways in which you can sort of manage the difficulty of the AI. More questions? Anything at all? I mean, not just related to this. I mean, Aryan can also join me now.
I think what we should do is let's
Yeah.
do some basic personal questions so that
Yes.
we can ask you about your journeys.
Before that, any questions on my side? I think most of that is quite
Yes, I
difficult.
will not.
Yeah. So, any questions in the models or how they work? So feel free. That's beautiful, right? Nothing. Okay, I think
I
it.
have a question.
Yes.
Yeah.
While we are given some text input to
Mhm.
convert to image,
Mm.
so this model we have trained it on previous images, right?
Hmm.
It's basically an image versus some number of captions. Like, for example, that DFGAN image I showed you, actually I trained it myself. So I took 5 captions against a single image, and then I trained it. So an image and a caption page is used to train it. There is something called DAMSM loss. Essentially, there are 4 loss terms that would become a bit difficult. I try to explain that in simple terms. You have 4 terms. One, you have the original text and the original image. Yeah, that you generate, that you have from the data set. That is used to train the discriminator, because you need a discriminator to adjust whether an image is relevant to a text, to the text or not. So that loss is used to do that. Then you take a permutation of fake text, the the randomly generated text, that is essentially against the image, and that you merge it with the fake images as well as the real images, and basically it's a permutation: fake, real, real, fake, 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 real, real, where the first value corresponds to the text that is there and the second value corresponds to the image. Now the fake image is what I call, that is generated from the generator that we had in GAN, and the fake text is generated by some embedding model that is used as additive to that step. I mean, you'll have to read it more. I mean, it's no way I can explain this in very simple terms.
In text to image converter, you said that जैसे कि
हाँ, speaking Hindi. Yeah.
text to image में आपने बोला था कि अगर कम टाइम रहेगा तो परफेक्शन नहीं आएगा
Hmm.
और अगर परफेक्शन आएगा तो फिर ज़्यादा टाइम लगेगा तो हमें डिसाइड करना
ये
है कि
एक्चुअली ये गलत है कि कम टाइम रहेगा ज़्यादा टाइम रहेगा, बिकॉज डिपेंडिंग ऑन मॉडल आर्किटेक्चर हम टाइम डिसाइड करते हैं. फॉर एग्जांपल गैन बेस्ड मॉडल्स जनरली 300 से 400 एमबी के होते हैं, उससे ज़्यादा होते ही नहीं. जो बहुत सोफिस्टिकेटेड होते हैं वो मैक्स टू मैक्स 20 जीबी जाते हैं. तो ये ये जो मॉडल का साइज होता है कैसे डिसाइड होता है? मॉडल के पैरामीटर से, मॉडल के वेट से। एक वेट क्या है? एक इंटीजर, एक फ्लोट पॉइंट वैल्यू, इंटीजर पॉइंट वैल्यू, डिपेंडिंग कि तुम क्वांटाइजेशन यूज कर रहे हो कि नहीं, पॉसिबिलिटी यूज कर रहे हो कि नहीं। तो एक वैल्यू है। अब जितनी ज्यादा तुम वैल्यू रखोगे अपने मॉडल में उतना बड़ा साइज होगा। तो बड़ा साइज है तो दैट मींस कि उसमें ज्यादा नंबर ऑफ पैरामीटर्स है। तो जनरल थॉट प्रोसेस तो ये कहती है कि भाई ज्यादा नंबर ऑफ पैरामीटर्स से ज्यादा मैट्रिक्स मल्टीप्लिकेशन होगी तो भाई टाइम ज्यादा लगेगा। बट इसका एक वो है एंटीथेसिस कि अगर आपका जो मॉडल फ्लो है उसमें आप सारे वेट्स मल्टीप्लाई नहीं करें बट कुछ स्पेसिफिक वेट्स मल्टीप्लाई करें डिपेंडिंग ऑन द टेक्स्ट, दैट इज कॉल्ड टेक्स्ट कंडीशनिंग ऑफ द मॉडल। तो आप कौन कौन से जो वो है एजेस एक नोड से दूसरे नोड तक, नोड्स क्या है? वेट्स है बेसिकली। एक मैट्रिक्स से दूसरे मैट्रिक्स आप कौन कौन से नोड्स एक्टिवेट कर रहे हो। तो अगर आप बहुत बड़ा भी मॉडल है लेकिन आप उसके कुछ स्पेसिफिक नोड्स यूज कर रहे हो तो आपका इन्फ्रेंस टाइम फास्ट होगा। एंड एक फैक्ट है दैट होल्ड्स फॉर टेक्स्ट एज वेल एज इमेज। जितने भी डीप मॉडल्स होते हैं मोस्ट ऑफ देम आर स्पार्स। स्पार्स मींस आधे से ज्यादा 60% वेट्स जीरो, तो जीरो या क्लोज टू जीरो, तो वो बहुत ही रेयर केसेस में एक्टिवेट होते हैं। तो इसलिए तो मॉडल ऑप्टिमाइजेशन पेस पकड़ रहे हैं बिकॉज भाई जिस वेट्स का हमें यूज ही नहीं आ रहा है जनरल पर्पस के लिए तो हम उसको क्यों यूज कर रहे हैं। तो ऑप्टिमाइजेशन जैसे प्रूनिंग था, प्रूनिंग मोस्ट ऑफ द केसेस बहुत अच्छा काम करता है इन सब चीजों में। इट वर्क्स वेरी गुड। So, to your question, it's wrong to say small model gives a smaller inference time and larger model gives a higher inference time. No, this is not the case. Depends on the model architecture that you are actually choosing. Anything else, or should we move to general discussions? Mr. Ed?
Let's start with general discussions. तो जब मैं फर्स्ट ईयर में था ना तो मैंने आर्यन भाई और हसन भैया की वर्कशॉप देख देख के सीखा है और उनकी वजह से मैं मोटिवेट हुआ था। तो आई होप आप सभी मोटिवेट हुए होंगे एंड थोड़ा बहुत समझे होंगे कि रीइंफोर्समेंट लर्निंग एंड जनरेटिव मॉडल्स व्हिच आर कैचिंग अप राइट नाउ इनमें what all things we can do and what else we should do. So I hope you all will go and explore yourself, right? Because अभी in this area, in this context, इतने छोटे से टाइम फ्रेम में covering everything in detail is not really possible. And I would like to thank them कि उन्होंने अपना टाइम निकाला और हमें समझाया। तो let's move on to some general questions. तो आप बीच में आ जाइए, आपसे पूछते हैं कुछ।
बंदी रहना ना।
नहीं ठीक है, आवाज़ ओके। तो लेट्स स्टार्ट विद आप लोगों ने अपनी एमएल जर्नी कैसे शुरू की एंड हाउ शुड दे स्टार्ट विद।
ठीक है, मैं बताता हूँ। मैंने थोड़ा सा बताई है। आई थिंक एमएल मैंने पहले मैं एस्ट्रोनॉमी के कॉन्टेक्स्ट में एमएल से इंट्रोड्यूस हुआ था। देयर इज this annual some workshop conducted by IIT Bombay's astronomy club in which they give you some task and you have to like complete it. So it is like something like winter of CP if you have done it. It like has 7 notebooks and you have to like apply some statistical techniques to do some astronomy related data analysis. So that is where I first got introduced to ML, and then suddenly pandemic came and then Coursera courses went free, so that is where all of us used those free courses to basically learn the basics of machine learning. And later then I worked on this project under a professor and then I joined Cynaptics club and yeah, then things happened.
Okay, so my journey actually started off with the workshop taken by my seniors. That was Google Explore ML. That was our year was the last year in which Google sponsored that program. From that year on, that program was so. From that year, I got introduced to what ML is, and it was a very good introductory workshop. Even if you are interested, they just type on Google ML, Google crash course, Google ML crash course. That is to say, just type that out. It's very similar to how you teach ML to a beginner. It's very simple and there's small prompts, a lot of videos. So sort of that was taught to us in the physical mode. Then from second year onwards, I took up research projects at IIT under professors. I worked on that. In my third year, I did research internships at NTU, NYU, and UCA, in which I got introduced, further developed my interest in machine learning as such. And yep, and actually, Cynaptics Club played a very big role in my development because we had a good batch of seniors that really taught us and gave the experience in a very lucid way. And yeah, it's the club that actually teaches you. I mean, we often feel that we can do ourselves many things, and we are ourselves capable. Everything is available on the net, but being in a club actually motivates you and get a good peer group in which you can collaborate and work upon. So yeah, that's
Okay. My next question was कि many of us here, I think, would love to explore ML as a career option, especially in research. So, if you want to go in research, what should we do? Where should we start?
Masters.
मास्टर्स में जाने थे लाइक आप लोगों ने रिसर्च इंटर्न्स किए हैं पब्लिकेशंस नहीं हैं आपके सो हाउ डिड यू गेट देयर
I think Aryan can answer this better.
Hasan, you can also answer it. Okay, so I just start just fast to say. So the basic thing is to start off with, you cannot just go on and just ask for foreign professors that if you want to do some projects, and even in industry. See, for undergraduates, the AI field is very daunting, and the big companies, as I stated earlier, they don't want to take just undergraduate students because they know almost zero, they know no maths actually. You know, the level of probability, knowledge on probability that you actually require, in fact, is of a very high scale, and that is why master courses are booming in the domain of AI. But from research point of view, to get into master's courses, you need some research publications, right? Because there, the value of MSGP is obviously higher. There's nothing like MTech. Even if there are, yes, very sparse. So to do so, it's better to have some research publications that you can get from your IIT professors, because they are the ones that you can approach them very easily. And once you have one or two publications, then you can leverage them to ask foreign professors or gain entry into research programs such as EPFLs. Some are at EPFL, and ETS Zurich also runs a program, and then there's Vanderbilt's and USC Viterbi. They offer good stipends, and even my tax, your seniors have gone there, so yeah. So you can leverage that. But to start off, you need some publications to show that you are actually oriented towards learning machine learning as a subject. For that, you can go and ask your IIT professors. They will be more than welcome to help you. They will give you simple tasks, code, and all that. Yeah, that would go a long way towards.
I mean, if I have to add, like, working under IIT professors is not really very difficult. Yeah. So, basically, you basically need to build sort of a CV or a reputation that you are capable and you know stuff and that you can do stuff. So publications is a very good way to prove your credibility again. So at our college, like almost every professor has some or other paper in machine learning, because nowadays anyone is using machine learning for anything. Even like professors in mechanical department, civil department, MUS department, they do machine learning. They want BTech students who know some amount of machine learning to work on their projects. So you can always approach those professors. Again, if you want to like do proper machine learning, then you can obviously go to professors in maths department or CS department. But if you just want to get started, you're not that you think that you need some starting point, that you cannot directly jump into the mathematics, and you want to work on something that is more application based, you can look at professors in your own department as well. So I think the best way is to talk to the professors who take your classes. Sometimes just mailing them also works. Or I think you should interact with your professors. You should look at the seniors who are doing their BTech projects that are related to machine learning. So you'll get an idea that this professor, he has some work in machine learning and so on. So that is how you can scout for professors here.
I think one burning question that everybody here will be having कि अब प्रोफेसर तो ऊपर हो गए उसके पहले कहाँ से शुरू करें?
PhD master students.
I don't think that was the question, right? You're asking for resources.
हाँ, like resources and how to start.
So have you shared the ML?
Yeah, we have shared the documents, but yeah, we'll be doing workshops. हमने एक beginner workshop की थी. We'll be doing workshops. We'll be having a challenge and stuff. So I think.
I'll give you a very high level idea. So machine learning is basically classified into two parts. One is deep learning, which most of the people want to do, and second is like non-deep learning stuff, which is like support vector machines, regression, and all of the other things, uh, like decision trees and so on. So a lot of people want to work on this deep learning aspect of machine learning. So I think both of them are quite independent. You don't need to have like very deep knowledge of simple machine learning techniques, like decision trees and so on, to essentially learn deep learning. So there are some good online courses. The one by Andrew Ng, that is very famous course. You'll find the entire playlist on YouTube. You'll find its assignments on GitHub, and I highly recommend that you yourself solve all of the assignments, the coding assignments that are associated with those lectures. That will be a very good starting point. And to slowly, as you discover your interest, to cover different topics, I think Stanford University has put out a lot of content on machine learning. So they have like literally, I think 10 or 12 playlists on different topics. They have like very comprehensive slides on different topics, and you can use those resources to build a theoretical uh, base for yourself. As for like practical applications, you'll get a lot of opportunities. You'll have several hackathons, several tech fests. We obviously have the Inter IIT. So there you'll get a lot of practical exposure where you'll code, you'll implement. But in order to get like the basics right, I highly recommend that you go out and check some of these machine learning courses, and make sure that you get your maths right. Study linear algebra properly if you have not studied it properly until now. Uh, and some amount of calculus, but I don't think that's a problem. Everyone knows enough calculus to do machine learning, but I think some amount of linear algebra, and as you progress forward, good understanding of probability also helps.
And to add to that, there's a very good course by HSC Russia. That's on Coursera, but you can find some crap on torrent or whatever sites there. So that is a course which I did after Android because I found and I mean Android is good for introductory business, but if you want to learn mathematical aspects of it, that is a very good course. It has 6 parts. It's a specialization: NLP, time series modeling, computer vision, and introductory ML and statistical modeling. And there is a additional course on competitions, which I believe Yatharth has been saying it multiple times that you must attend competitions. So you can go and look up that course. It's sort of mathematically intensive. It would take you some time, but once you do it, you will have a very good understanding of everything. And try to perform Google searches as much as you can. Sometimes there are very good Medium articles. Sometimes there are websites like Analytics with Vidya or Medium and towards data science. You can find multiple things there. But that would require effort from your end because it's hard to find a resource that spoon feeds you.
And I would also recommend that you study in bursts. That is, don't study something and leave it for 4 days and then come back to it. Study in bursts of like complete one topic, understand it, like code it, do everything together so that you build a comprehensive knowledge base. Otherwise, people tend to forget what they have studied earlier, and when they start implementing the codes, or when they revisit that thing, they tend to forget everything that they had studied earlier.
And just to add, as you're moving on to the second years, and those who are in second year will be moving on to third years. So just a question I wanted to ask: how many of you know PyTorch? So only so there are some people, but not many of you do. The reason why I'm saying is because when we talk of competitions like Inter IIT, right, or maybe some high level competitions that are there, so mostly there you have to deploy your own custom model. I believe most of you know might have in participating in machine ML projects and stuff, they must be using Keras, right? So I hope everyone knows Keras. Yeah. So Keras is a very high level library. I mean, it just gives you pre-made blocks that you just put in code and done. But PyTorch is a language that allows you to build your models from scratch. Reason why I am stressing on PyTorch over TensorFlow, which most of you are aware of and have a good knowledge about, is because it is very difficult to create custom models in TensorFlow because they, hmm?
Like they have a weird syntax also. Right?
Yeah, and you have to write your custom loss functions. PyTorch has a capability that automatically calculates your parameters that you want to do, and it's just a simple single line of code that you need to train your model. So I urge you all look into PyTorch. There are various YouTube tutorials available, and just saying that if you are into developing models or you look forward to developing models in different domains, then you must know PyTorch.
Okay. I think we have covered all the basic questions. I hope everybody is interested. Any other questions from anybody to ask them? Like when I was in first, when they were in first years, what they were making was a brain-computer interface, like taking your EEG signals and making a computer interface, training a model to walk from scratch and all that stuff. And you guys are thinking like we didn't do it yet. So yet is the crucial part. We will be getting you some projects for yourself because let's say you want to move into this field, right? You want to move further. So you need to actually go into what's going on and actually learn. So we'll be going there. So if you have any questions about anything, any even questions like how to I allocate time, like many of you, when I was in first year, I used to have the issue that I could not think that I should do this, I should do web development or ML or any other field. Like there are so many fields. What should I do? What should I focus upon? So how do I dedicate time? So any question, anything, any from anyone. Same question. Okay. What question? Please rephrase.
Optimized
So
question.
there's we have fields and like C we have CP, web dev and ML, and so how to allocate time and yeah, and
Yeah, so I think first of all, these are not mutually exclusive. If you are doing one of these, doesn't mean you can do anything else. Like obviously, you need to do DSA. That is a good thing to do. Then web dev is like a really easy thing to do. Then machine learning is where you have to put in effort and wherein your reward might be variable. Not everyone will get a machine learning job or an intern. So I think you should do machine learning because if you have interest, if you are planning for a master's, not just now, say after working for 2 years or 5 years from now, and especially if you are interested in machine learning, you should definitely do it. I mean, there is no reason to do something that to not do something that you are interested in. Uh, so in allocating time, I think you'll have like in a semester you'll have different phases wherein you'll have different events, and you can make your plan, according to that. For example, you can do DSA regularly. However, if there is some event related to web dev, near about that time you can learn more about web dev. And if there is some hackathon related to machine learning coming up, you can start preparing for it for like 1 month before that, and that's how you can cover like a lot of part in ML. Then you can take up project under a professor. The professor will try to keep you accountable. So that's how you'll be forced to dedicate time into doing machine learning. So you need to establish some mechanisms to make yourself accountable, so that regardless of how you plan, you end up putting the required amount of effort into whatever field you are choosing.
And talking on a very selfish perspective, see, everyone of your batch would be doing DSA, right? But what makes a CV stand out? It's the projects. And when recruiters, especially those hiring in ESG domain and all, and they see ML projects, so they might field interview questions based on those projects even.
Yes.
We have had our batchmates who had ML projects and their entire scope of interview was focused on that because ML is a field that is here to stay at least for some time because ChatGPT 4 has come up and web dev wouldn't be a job anymore. Yeah, if you might have heard ChatGPT 4 can generate websites out of system models. That's a big thing, but yeah. So use it as to boost your CV, not just to do projects, because obviously you will be having your knowledge, and as Hasan very rightly said, sooner or later in your career, 4 years, 5 years, you'll be working somewhere in the field of ML only. So yeah, it's a good thing, and on a selfish perspective, use it to boost your CV.
Yeah, even like for example, I'll tell you my interview thing. So when Fractal came for the internship, so they were offering like several profiles, including machine learning engineer and data scientist, some other profiles as well. So for me, the questions were focused only on the projects that I had made. So basically, what I did was I presented my screen and I showed them the PPT of which I had presented in a conference somewhere else, and they were very impressed, and it just kept on asking questions with respect to that only. So they didn't have enough time to ask other questions, and they liked it quite well, and so I ended up getting the intern. Even in some SD interviews, after like the DSA rounds are over, sometimes the questions are on projects, and if you have like a copy paste project from GitHub, it is very easy to spot. And instead of doing that, it is better to do some good quality projects, and machine learning projects usually are quite good quality projects, and uh, some amount of attention it can capture for the recruiter. So you can ask some questions there as well. And it is usually, very uh, easy to answer questions that are being asked on ML projects, because if you have done an ML project by yourself, you probably understand 80-90% of it. When compared to some GitHub code, some website that you have copied from somewhere, and you're just putting it in the CV.
Yeah, that is actually true. These projects may are good, but the thing is that you have to be consistent, as Hasan said, because I've seen your third year and second years, they take up ML very enthusiastically in the first and second year. Then they leave it because they often are torn between what all things they should do. Most of them are in 3 or 4 clubs in the first year. I mean, most of you would be there exploring, and then later on drop them in the second or third year, and at the end they feel that, oh, I've been in so many clubs, that is good, but I haven't been able to do justice to any of them. So I believe Hasan would agree with me on this, that now you are in ending your first year, so it's time that you make your decision on what you want to actually do. Pick up 2-3 clubs. If you wish to pursue machine learning, you can choose any of the clubs. Though I will obviously vouch for Cynaptics club because it's their workshop, but it's high time that you choose your clubs right. There's no point in being 6-7 clubs just for the sake of it, because at the end you'll be getting nothing. And I tell you for a fact, the PORs here in our college don't mean nothing. Those who write like I've been a member at this club, I've been a member at that club, it just makes a dent on your profile. That's all. So don't get under that impression that if I'm a part of 4-5 clubs, then I have a very good profile. No, it's your projects that matter.
I think the more important factor is that what you have done after joining the club. So that is what makes a difference in your CV. For example, if you write you are a member at Cynaptics club, it doesn't mean anything. You just joined it. But if you are writing you have a gold medal in Inter-IIT as a part of Cynaptics team, that means something. Okay, so try to gain meaningful. Try to get meaningful outputs from your clubs. Try to do some good projects. Try to win competitions. That is the approach that I would suggest. And in case you are not able to decide what you want to do with your future, that's okay. Still, you should choose something. Even if you are like not 100% committed, you are like 80% sure that I want to do this. 20% in the back of your mind, you are like, yeah, I can do this as well. Even in that case, I think you should commit to one particular path, because in the end, the depth of your knowledge matters more than the breadth of your knowledge, and that is what will be helpful. Because honestly, even after 4 years of BTech, there are many people who don't know what to do in their life. Even if they might have some placements and they might be earning money, but they might still not know what to do in their life. That's okay. But still, you should, pick something and put effort in that field. So that even if you don't like it 100%, you get good at it.
I think everybody's getting tired, so we'll be wrapping it up. If anybody has any questions, anything you want to ask, I think they have already told you what to do, where to go from here. Pick something, pick any field. Yes, I'm standing here in senior interaction with Synaptics and machine learning. But yeah, if you have anything you're interested in, pick that. Do justice to that, and if you are interested in machine learning, we'll be hosting workshops, competitions. There's going to be a Kaggle competition going live on Sunday after the workshops, where you will be applying your NLP skills that you gain in the workshop. And yeah, projects matter, yours don't matter. Easy summary. And I would say nowadays, when we are in a time where machine learning models are writing websites, where they're writing our assignments, they're doing creative work. Picking up machine learning is the best thing to do and the safest option to do. So, I think
One
we
thing more I would just like to add that on my part, in my first year, I had this itch that I usually felt that I do not have the prerequisite knowledge to participate in competitions. Even after the introductory ML workshop, I was like, oh, what is this? I don't know anything. This is just videos and I don't catch a thing. And that is why I've restricted myself from participating in competitions because I used to feel that if I don't have the knowledge, what would I do in that? That would be a waste of time. That what I used to feel, and I believe most of you would share this concern, right? So to that I would just say, participating in competitions is the sure shot way of you learning something because you have a competition, so you would search on Google, stitch some code over and over, and you would make something. At least if it doesn't perform very well, but at least you know how you stitch that code. And let me tell you for a fact, for undergraduates, it is totally fine if you take the code from multiple places and stitch it together in machine learning because you are not expected to have knowledge. I mean, we are not expected to have knowledge about the mathematics of that. So for us, it is perfectly fine if we are referring to some online resources or maybe even using the code and copy pasting it blatantly even. But the question is, are we copy pasting the right thing? Are we stitching the right thing? Are we doing it the right way for the target application? At least if that much knowledge we are able to get, then we are at a very good level with respect to our peers, right? So my only advice is don't budge from participating in competitions, especially in inter-IT, because for the last 2 3 years, it has been seen that people are very hesitant to participate in inter-IT because they feel that it is a competition of a usually large magnitude and they cannot keep up with it.
Yeah, the problem statements also seem like quite difficult if you just read it. But the fact is that even the fourth years or like even MTechs will not immediately know what to do. They'll have like some vague idea. You have to go in, you have to read papers, you have to research, and then find out what to do. That is essentially the point of the competition. If everyone generally knows the answer to some given ML problem, then there is no point putting that problem in an inter-ID, right? So yeah, don't hesitate. Try to participate. I think doing is the best way of learning.
Yeah, and it is perfectly fine to copy paste and cross stitch your code and do jugaad, whatever because it is.
You slowly absorb the structure. Like when you copy paste, you observe, right? And slowly when you then from copy pasting, the next step is like you start modifying those models, and then finally you'll be able to write your own models. Do it like step by step.
So, yeah, that's true. I mean, first you just put, for example, in a text modeling problem, you put 5 LSTM layers and you think, okay, this is working. You took a pre-trained model, you use it to generate predictions, you think that it's working fine, and slowly the progression happens. If you think that in one setting or in one short burst of time you will learn everything, then that's not the case. Even to talk about it, I even don't know many of the things that are there in the current state of the art models because obviously the mathematics is very hard to observe if you go there. Especially as I talked about diffusion foundation models. I mean, within there is so much. I mean, as you open the research papers, it would seem very daunting to you. But you have to start somewhere. Start from cross-stitching your code, and slowly you will know how to actually develop your own models. And that's where you want to reach, ideally, at the end of your fourth year.
So I think to sum it up now, I think keep trying, keep learning, and try to not get replaced by AI. A big round of applause for our seniors. So everybody on Sunday in the workshops so that you learn some NLP and some basic applications. Bye bye everyone. Thank you for coming.